Okay, we are going to try to solve an exponential equation using the uniqueness property. First, let's state what the uniqueness property is. For all real numbers m, n, and b, where b is greater than 0 and b not equal to 1, if b raised to the mth power equals b raised to the nth power, then m equals n. So what that really says is if my bases are the same, then my exponents are equal. Alright, let's put some examples up here that we want to work using this property. The first one, 100 raised to the x plus 2 is equal to 1,000 raised to the x. Now upon first glance, you might think, well, these aren't the same base, and you would be correct. They aren't the same base. But what we can do is perhaps rewrite one or both in such a way that they do share the same base. Now something I know about 100 and 1,000 is that they both can be written as a power of 10. 100 can be written as 10 squared, so the left becomes 10 squared raised to the x plus 2. 1,000 can be written as 10 cubed, so we have on the right 10 cubed raised to the x power. Alright, it's getting better, but I'm not quite there. Now I have to apply my exponential properties. I'm going to raise a power to a power, which means I multiply. So on the left, I'm going to multiply that 2 to the x and the plus 2, and I get 10 to the 2x plus 4 on the left. And this is equal to 10 to the 3x. Now my bases are the same. So according to the uniqueness property, my exponents are the same. So I can now set my exponents equal to each other and solve. I'm going to move my 2x to the right because that keeps everything positive, and I get 4 equals x. Let's go back in here and check to see if it worked out. It's always a good idea to check your work whenever you can. So the left, if I plug in 4, I get 10 to the 2 times 4, or 8 plus 4, which is 12. And does that equal 10 to the 3 times 4, which is also 12? It does indeed. So x equals 4 is our solution. Let's work one more that might involve a negative exponent. Clear some of this off. And let's do another. 1/2 raised to the 3x equals 8 raised to the x minus 2. Again, you see that we do not have like bases on both sides of our equation. But I do know that I'm seeing a 2 in common with both. I know that 8 can be written as a power of 2, and if I remember my exponent rules, in particular my negative exponent rules, I know that 1/2 can be written as 2 to the negative 1. So the left becomes 2 to the negative 1 to the 3x, and that equals 2 cubed to the x minus 2. I'm almost there. Let's distribute our powers. We get 2 to the negative 3x equals 2, and remember I'm going to distribute that 3 to both terms, 2 to the 3x minus 6. Now my bases are the same, so I set my exponents equal. Negative 3x equals 3x minus 6. If I attempt to solve for x now, I get negative 6x equals negative 6. Divide both sides by 6, negative 6, excuse me, and get x equals 1. And that is my final answer.